Guys, we are going to be talking about finding the area between two curves today. It's going to be awesome. Not as awesome as having a new baby in the house, but pretty awesome that we're talking about this. And let's start out just by putting our name on the top. Mr. Benson. There we go. So let's talk about finding this area between two curves. Well, let's first start off with having two curves, and let's have an area between those two curves. So say I have this top curve F right here. Let's make that one red. And I have this bottom curve G, and it only makes sense to make that one blue. And we want to find the area in between the two curves. Thus, we want to find red and blue. And red and blue, if you mix them together, you get yellow. Right? I know that's not right, guys. I didn't know. I wasn't sure. So we want to find this region between these two curves, starting from A to B, bounded by kind of these two integrals. Well, you've been doing stuff like this before. You could do this. This is nothing super extreme new, guys. Really, the only thing you have to do is first, you got to figure out the area under f of x, okay? You just got to figure that out. So the area under f of x would be the integral from A to B of f of x dx. Okay, that's the area under f of x from A to B. Okay, then what you need to do is find this area under g of x, this blue area right here. Okay, you need to find this area. So to find that area, you'd be integrating from A to B, right? A to B, this g of x function right here. So g of x dx. Okay, so we're going to integrate that. And if you want to find the area, this yellow area right here of these two functions, you just take, check it out, you just take this and you subtract, no, I got to put it all together. You subtract this one from it. You just subtract the two, okay? And if you remember all your integration rules and all the things you can do with them, you can take both of these integrals and combine them into one on the outside. And when you do that, guess what you got? This right here. This is our formula. The formula for finding the area between two curves. You integrate from A to B, in this situation is A to B, of this function minus this function, f of x minus g of x. Now, why is the f of x first? You might be asking. Well, check it out. The f of x in this entire interval from A to B was on top. You could also say above, right? That would be another word for that. And this one right here, this g of x was below, because the other one was on top, so the other one's below. So because the f of x was on top and the g of x was below, we have the f of x minus the g of x function. And that is how you find the area between two curves using this formula. We're going to show you how to use that formula later in this lesson. Team, if you go back to the beginning of chapter 5, we started talking about finding the area under a curve. Was that chapter 5 or 4? I don't remember. One of those chapters. That's not the important part. The important part is what we started with was rectangles. We started finding the area under this curve using not just a billion, not just a trillion, but like more than a trillion rectangles. Infinitely many rectangles, just like this one right here. And we found all these rectangles and we just added them all up, and that gave us the exact area under the curve because these rectangles were infinitesimally skinny, right? Well, we can use the same idea for finding the area under the curve using rectangles, or sorry, the area between two curves using rectangles. And using that, and just it's almost common sense, but I don't want to say it is, just like what we were talking about before, to find the area of a representative rectangle right here, to find the area is equal to height times the width. That's this rectangle that they're talking about right here, okay? And the area of a rectangle, right, in this situation, because the height of this rectangle right here is f of x and minus g of x right here. This is our g of x. So that's the height of the rectangle given, right? H-E-I-G-H-T. Oh, I guess it's right up here, so I don't need to write it again. And the width of the rectangle is given by delta x, which gets infinitesimally, super ridiculously small, right? And that's how we add up all these things to find the area under the curve. And then, so what this started is we then add all these areas up, right? To add all these up, we use this cool thing called the limit. As the number of rectangles approaches infinity of this function given right here, this actually leads to the integral we found up here. And that's why we can use that integral up there. So there's really nothing to write down here. We just wanted to show you where does that come from. You maybe just says a common sense up here where this formula comes from right here, but this is just another way of just thinking of where it came from. And now we're just going to see how we can apply this formula for the rest of this lesson. So in this first example, we are going to find the area of a region bounded by y equals x squared, the function y equals negative x, and x equals 0 and x equals 1. And that function is represented, or the drawing of this area is represented right over here. Up on top right here, you have the y equals x squared plus 2. This is that right there. And then the y equals negative x, that's given by this function right here. And then the x equals 0 and x equals 1, well, that's given by these two lines right here. So you get this region is what we're looking for right here. This purple region right in the middle, or already shaded in region. So now that we have all this information, we just need to set up this integral. Now, the first thing is you want to set up how far left and how far right are we integrating this. Well, this given by here, our lower bound is our 0. So we're going to go from 0, and our upper bound is our 1 right there. So we're going to integrate from 0 to 1. You can see that these lines are right here. And then what we're going to need to do is we're going to have to figure out which function is on top. Well, that's easy to see. It's this red function. This y is equal to x squared. So that's the top function. So we would put that one first. So we have x squared minus or plus 2. That's going in for our f of x, right? And then we have the bottom function, which is this blue function right here. And that is going to be subtracted from this function. So we're subtracting negative x, okay? And then we have our dx right there. So now that it's all set up and ready to go, let's just do this. Okay, so we're integrating. Oh, I should not do that color. That's a bad idea. From 0 to 1. Let's simplify this inside first. X squared minus negative x plus 2. So this is really x squared plus x plus 2 dx. So now let's integrate this. First we'll do the integral. So the antiderivative of x squared is x to the third over 3. The antiderivative of x is x to the second over 2. And the antiderivative of 2 is plus 2x. We're going to evaluate that at 0 and 1 and subtract the 2 from each other. So now that we've done that, let's take this 1, plug it in here, here, and here. When I plug the 1 in there, I get 1/3. Plus, for this one, I get my 1/2. And for this one, I get my 2. Okay, that's plugging that in there. And now let's plug the 0 in here. Well, that's 0 when I plug it into that one. And that's 0 when I plug it into that one. And that's 0 when I plug it into that one. So I'm subtracting 0 plus 0 plus 0. That was the easy one. So now I'm just going to focus right here on this. 1/3 plus 1/2 plus 2. Let's get a common denominator. Last I checked, it was 6. So I got 2 over 6 plus 3 over 6 plus 12 over 6. 2 plus 3 plus 12 is 17 over 6. So the area of this purple region right here, bounded by this curve and this curve, from 0 to 1, is 17 over 6. Okay, now in this next problem, it wants us to find the area of the region bounded. That's a key word here, guys. Bounded by f of x equals 2 minus x squared, and g of x, which is just equal to x, okay? So we have these two functions right here. Now, the first and most important thing to do is be able to visualize what's going on. So the first thing you probably want to do is try to graph this function. So I want you to take a minute and just graph it on your screen. Think through what these functions are, graph it on your graphing calculator, whatever you need to do, but make a graph and put that graph right here on the screen. And while you're doing that, I'll graph it too by enlarging this picture that I already graphed and placing it right here, just to save on time. Okay, so I got this graph here. I spent a lot of time graphing it. And now I'm going to take a look at this graph and think about it. I want to find the area of the region bounded by these two functions. The f of x, which looks like it's the top function, so I'll make that one red just to match my graph. And then the g of x, which looks like it's the bottom function, and that's blue. And that's this one right here. So now we want to find the region bounded by it. Well, that's just the region in between this, okay? Now this problem differs a little bit from last one, that it doesn't give us an upper bound and a lower bound in this one. Well, that's because you got to figure it out. But you guys can do that. All of you can do that. You just have to really just kind of do a little algebraic manipulation here, do a little solving, things like that. Let's just say the graph wasn't there and it wasn't accurate and we really didn't trust this. It looks like if this is going up by 2's, which I believe it is, I could be wrong. This should be 2, 2 right there. And this right here, I'm just guessing. Let's just see if this is right. And this should be -4, right here. This should be -4 comma -4. Let's see if that's what we get. Now, we're going to figure that out algebraically, and to do that, first what you have to do is you got to take this function and set it equal to this function, and then solve them. Okay, so we'll do this right. Let's do this over to the side here. So we got 2 minus x squared equals x. We want to figure out when that happens. That will give us this point right here and that point right there. Okay, or our x coordinates of those points. So set this equal to each other. Now let's get everything on one side because we can do that. So we have 0 is equal to x squared plus x minus 2. Now let's factor this because I think you can. Okay, this would be x, this would be x. What times what is -2? That adds together to be 1, and the -2 is negative and it's positive, so this got to be the positive one, this is negative. So we factored it, and now thus our x values are x is equal to, oh, did I do this wrong? Why does that graph look all weird? Then it must, oh, okay, I get it. I misjudged on the things. Okay, 1 comma -2. So we know that we have one x value at 1, so this isn't 1. I'm sorry, guys. This isn't 2, 2. This is 1, 1. And since the other value is at -2, this one, instead of being -4, should have been -2, -2. How silly of me. How silly. So this should be 1. These are all 1. That should be -1, 1, and then -1. Okay, so now we know what our bounds are. Check it out. One bound is right here, -2. This is our -2 bound. And here's our next bound. This one when we stop integrating right there. At 1, we stop integrating at 1. So we can set up our integral now. We are integrating from -2 to 1. Okay, that's our integral. Now, remember, we're integrating from -2 to 1, and then we're going to do our top function minus our bottom function, right? Our f of x function minus our g of x function, dx. Now, what is our top function? Well, our top function turns out to be this function right here. So we're really going to integrate from -2 to 1 of 2 minus x squared. And then our g of x function, which is right here, we're going to subtract that because that's the bottom function right here. So we're going to subtract x in this situation. And then we got our d of x. Now it's just a matter of integrating and simplifying. Yeah, get out of my way. Get out of my way. Okay. Ooh, my wife's calling. Time out, everyone. Hey, sweetie, what's up? Are you okay? You gonna come out my way? Because I can do that for you. I'd be willing to. We got Noodles and Company. We got. Oh, there's we could go to Buffalo Wild Wings. B-dubs, because he loves that. Some of my students work there. Are you gonna meet me here and then go there? Okay, so call me at the back door. Love you. Bye. Oh, sorry about that, everyone. So, B-dubs tonight. It should be a good time. Okay, so now back on track. Let's focus because she's going to be here any 10 minutes from now. So we're going to integrate this function right here. So let's do that. Let's simplify it first. So we're integral from -2 to 1. This right here changes. This is -x squared minus x plus 2 dx. Okay, now since you got it set up to be an integral from -2 to 1 of this function right here, I'm not going to go any farther. This is a polynomial. You've integrated many times. I know you know how to do this. The main focus right now for me is to make sure you understand how to set these things up, and this is the main setup of a problem like this. In the next problem, I'm going to do something a little bit similar, but check it out. In the next problem, this is what's going to happen. Say we have this function over here like this, and let's say it like now it pops up again. And now we have another bounded region. We got to figure out how to handle a situation like that where we have two separate bounded regions like that. Okay, so that's what you got something to look forward to now. Here we are, the last example, and then I can set you guys free. We want to find the area of the region between two functions. The first function is f of x, which is 3x to the third minus x squared. Oh, minus 10x. And then the next one is this function g of x, which is negative x squared plus 2x. Okay, so those two functions were graphed for you right down here. Now step number one is just kind of taking a look at the graph, seeing what we're going to do. What are we going to do with this graph? That's what you're asking yourself. What are we going to do? Well, what I'm going to do is I'm going to first start filling in some red here, just kind of distinguish which function's which. And I notice that sometimes one function, the f function, is above the g function, and sometimes it's not. Okay? Thus, and vice versa, sometimes that g function is below the f function, and sometimes it's not. And we got these two bounded regions going on here. The first bounded region is this one right here. This is the yellow region. We'll call this yellow. That's a good name for the yellow region. And then the other one is this blue region. We can call this one blue. Our blue region. And we want to find the area of both of these regions right here. And really what the setup is going to be like this. We are going to find the area of the yellow region. The yellow region right here is going to be this integral of the red function, right? The red function is our f of x function. So the integral of f of x minus g of x, right there, that's this yellow region. And the integral is going to be from this point, this x coordinate, to this coordinate right here, which looks like it's obviously 0. Okay? And then this blue function, Mr. Blue function, is going to be another integral of now, because the g function is now on top, see how the g function is on top? It's going to be g of x minus f of x, because the f of x is below, integrated from this x value to this x value right there. Okay? So that's what we're going to be doing. We're going to try to figure this out, put this all together. Once we put it all together, we're going to take this integral right here, and we're going to add it to this integral right here with a sign that looks something like this, the addition sign. Okay? So let's set this up. The process is just the same as before. We got to figure out what these points are. This point, and this point. Okay? So let's do that. And to do that, what you need to do is you need to take the g of x function and set it equal to the f of x function. So we'll do that over here. So I got negative x squared plus 2x is equal to 3x to the third minus x squared minus 10x. Okay, now let's get everything on one side. I'm choosing to take this stuff and put it over on this side because I like this being positive right here. So let's add this 2x there. We're going to have 0 left over here. I got 3x to the third minus and another minus. Oh gosh, the x squared just go away. Isn't that nice? Nice of them. Oh, forgot the x there. And then we'll subtract that, so minus 12x. Okay. Oh, that's nice. So we got to find our zeros. What makes this 0? So let's start factoring. I got zeros equal to, I'll factor a 3 out of both these two terms, and I'll factor an x out of both these two terms. And when I do that, what I'm left with is, in this term right here, this one, I have an x squared right there, and in this term I'm left with a minus 4, because 12 divided by this 3 right here is 4. Okay, so I'm not totally factored yet. I got zeros equal to 3x. And this x squared minus 4 is really x plus 2 and then x minus 2. And there we go. We are completely factored, and now we know what the values are right here, right there, and right there. One value is given from this one. How do you make this whole thing equal to 0? Well, this has to be 0, so we have an x is equal to 0. That will be put right. Nope, it's going to be in this one right there. And then we have another value given from this one. This would, to make this equal to 0, so this whole thing is equal to 0, we got to put in a negative 2 there. And the same for this one. We have to put a positive 2 in for this one to make that equal to 0. So we found our bounds. Our bounds are going to be, this is going to be our negative 2, this is going to be our 0, this is going to be our 0, and this right here is going to be our positive 2. So let's just put it all together. I'm not going to integrate it for you guys. You know how to do this. I don't have to show you how to do this anymore. I'm just going to put it all together. So the first function, Mr. Yellow, this one right here, I would do it in yellow, but you probably won't be able to read it. We are going to integrate that from here. This point was negative 2. So from negative 2 to this one value right here, negative 2 to 0 of our f of x function, because f of x is on top. So our f of x function is 3x to the third minus x squared minus 10 minus our g of x function, which is negative x squared plus 2x. So minus our negative x squared plus 2x, okay? And then we're going to add that to our next integral. Now we're going to focus on this one right here. So this one is integrated from 0, which was right there again, right, to this value, which was right here, the 2. We got that from right there. Integrated from 0 to 2. And now we're just flip-flopping it. Now it's going to be our negative x squared, that's first, our g of function, right, plus 2, minus, and our f of x function, 3x to the third minus x squared minus 10. There we go. There it is. Now, it's pretty ugly right now, right? I really haven't done much to like simplify it. You guys can go a little bit further and simplify it. You know, you could bring this with this. Things cancel out. I'll simplify it for you guys. That would be fun. Okay, so we got negative 2 to 0. This is still a 3x to the third. This and this cancel out. This is an x. Wasn't that an x? Why did I forget that from before? Yeah, that's an x. And this is an x here too. So, and then we got negative 10x minus 2x, so minus 12x for that one. And then we're going to add that to the integral. Oh, got to get your dx, guys. Sorry, I forgot my dx's there. Don't forget those. Did I get them up on top here too? Oh, shoot. Butler would not be happy with me. He would not be happy with me. Okay, and then I'm integrating from this one from 0 to 2. And then I got this and this cancel out. I forgot the x there. Wow, guys. How many mistakes did I make? Did I forget the, yeah, I forgot the x there. So I got my 2x minus a negative 10x, so that's a positive 12x. And then this is a negative 3x to the third right there, dx. Now you can integrate this one, integrate this one. I'm not going to show you how to do it because you know how to do it. And that's what this is all about. This lesson's all about that. Right there. Doing these steps right here. So we're setting we're setting the footings for doing some really cool problems when we come back from spring break. The problems, I don't even like know how to do them yet. Well, I do, but I haven't practiced them for a while. Just imagine you have, like, say this graph right here, and what we're going to do is we're going to take this graph, check this out, and we're going to rotate around the x-axis or even maybe the y-axis right here. And when we rotate around, we're going to try to find the volume of this graph. And to think about rotating this around, it's going to make a circular shape. And what we're going to do is, instead of finding the area of a rectangle, we're going to start to find the volume of these circular discs right here. This is a circular disc. And we're going to add all these circular discs up and find the area of something rotated around, something like this. Some weird shape like that. So anyway, something to look forward to. You got everything you need to be successful on 6.1. The homework, I don't know what it is, but I'll make sure it's up on the board. Just look over at the calendar right now and you should be good to go. You guys are awesome, and then I can't wait to see you guys after spring break. I'll send some pictures your way. Take care.